Okay, in this video, we're going to solve this problem using the method of Laplace transform, and we need some formulas here. So some of the formulas we're going to use is the Laplace transform of a y prime is equal to s y of s minus y of 0. Laplace transform of y double prime is equal to s squared y of s minus s y0 minus y prime of 0. We're also going to use the Laplace transform of UAT is equal to 1, is equal to e to the negative as over s. So for this problem here, we'll go ahead and find the Laplace transform, take it to both sides. So we go ahead and do that, and we'll use linearity also along the way. So we have Laplace transform of y double prime plus 4 Laplace transform of y equals 4 e to the negative 2 pi s over s. And now I'll go ahead and use the formula for y double prime. So that's going to be s squared y minus s y0 minus y prime of 0 plus 4y equals 4 e to the negative 2 pi s all over s. So it was chosen sort of conveniently that to make it the problem a little easier to do, shorter, to just let the initial conditions. Oh no, sorry, I was saying the initial conditions are both 0, but y of 0 equals 1. So, y prime of 0 equals 1. I thought they were both 0. Okay, so I better definitely not make that mistake. So this is s squared y minus s times 0 is 0, so it's just going to be minus 1 plus 4y equals 4 e to the negative 2 pi s over s. So then I'll group the terms that have y, and then I'll add 1 to the other side. And so then this will give y s squared plus 4 equals 1 plus 4 over s e to the negative 2 pi s. So y is equal to 1 over s squared plus 4 plus e to the negative 2 pi s, 4 over s squared plus 4. And then little y is equal to the Laplace inverse of 1 over s squared plus 4. The s squared plus 4 is s squared plus 2 squared. Well, there's a little more to it than that. Let me just, yeah, okay, I'll put it like that. S squared plus 2 squared. Okay, and then plus. Now when I do this Laplace inverse, I wanted to use yet another formula. So the thing is that the formula I want to use is Laplace transform of sine bt is b over s squared plus b squared. So I'm going to use that. I'm going to use that one. I can use that over here. But in order to use that, I need 2 on the top. So I put 2 on the top and I divide by 2. Is that too slick there? But that's what you have to do. And then you get sine of 2t. For this, then I have another formula yet. One more. Laplace transform of UAT, f of t. Not f of t, sorry. I want to write f of t minus a is equal to e to the negative as fs. Okay, so for this one right here, this has the e to the negative 2 pi s. You have to sort of focus on that. So this is going to give plus u 2 pi t. And then what I need to do is I need to find the Laplace transform inverse, the inverse of this piece right here that I'm circling, but then shift it by a, where a would be 2 pi. So the way I'm going to write that, even though it might not suit everybody's taste, like someone might say that's even junk the way I'm writing it, but we'll just have to go with it, is I'm going to write that as t minus 2 pi. So I'm going to see the Laplace inverse is going to be a function of t. So even though I still have s there, I'm just going to do that. And then I'm going to put it in t minus 2 pi. That's a good way. That's a way to write it. Or you could write another way that maybe I could also write this is I could say, well, this is g of s. Yeah, maybe I'll do that. And then if this is g of s, or even f, whatever, but I'll use, well, if I'm using this formula, I call it f. Okay. Then I'll put f of, I think I'll just stick with g. Okay, the way I was doing it is fine. It's just a question of the way you want to write it. So g of t minus 2 pi. So where this is g. Okay. So it turns out I need more paper. Surprise. Okay. More paper. Okay. So g of s is equal to 4 over s squared plus 4. And what I need to do is I need to use partial fraction expansion. 4 over s plus 4 over s squared plus 4. That's not what I want to do, sorry. I want to write a over s, bs plus c over s squared plus 4, okay? So why would I do that? Because this is irreducible, does not factor. Some people would say, well, let's go into factoring over imaginary numbers, but I'm not going to do that. But that might be a good way to do it, but it's not what we're doing right now in this class. Okay, so I expand that and I get, I clear the fraction, and I made a type mistake right there. And so I get that, and so the thing is, I mean, there's different ways to do this, but one is you could write this as 4 equals as squared plus 4a plus bs. So it occurs to me that maybe they made a mistake along the way, but so, okay, as squared plus bs plus 4a is equal to 4. Oh, I see I did wrong, sorry. I don't want to start the whole video over. I don't know if I did the whole thing wrong, but anyway. 4 is going to equal s squared plus 4 plus bs plus c times s. All right, sorry. Okay, so what I'm going to do is I'm going to put in convenient numbers like s equals 0. We've seen this problem in so many other videos, so I put in s equals 0 and I get 4 equals a 0 squared plus 4 plus 0. Putting in x equals 0 kills this and gives 4a equals 4, so a equals 1. Highlight it. Then I can put in, so I have 4 equals 1, s squared plus 4 plus bs plus cs. So I put in 1 for a, and this time I'll put s equals 0. Why? Because that will kill the b term, and we only have b and c left. So 4 equals 0 squared plus 4 plus b times 0 plus c. Yeah, this one is actually, in fact, a little easier. Putting in s equals 0 is going to kill this piece right here, but so that's not going to do it. Let me instead just multiply this out. That's sort of what I was doing before. Okay, so the 4's cancel out on both sides. These 4's cancel out. And we get 0 equals s squared plus bs squared plus cs. So apparently then 0 equals s squared b plus 1 plus cs. So b plus 1 equals 0 because on the left-hand side we have 0 s squared. And then, so that means that b equals -1. And then also this is cs equals 0s. So c equals 0. All right, so I know I sort of slowed down on that. I'm doing a bunch of these problems. So g of s, no excuses though, is 1 over s plus bs plus c, but b is -1, so it's -1 over s squared plus 4. And see, the Laplace transform of 1 is 1 over s. Laplace transform of sine bt is b over s squared plus b squared. So, all right, so g of t is going to equal 1 minus Laplace transform of this, except I will put in another line here. G of s is equal to 1 over s plus -1, 2 over s squared plus 2 squared, but I introduced a 2. So I multiply by 2, I have to divide by 2. So it's going to be -1/2. When I do the inverse, I'll get sine of 2t. Okay, now what did we say? Y of t is equal to, all the way up here, we said it's 1/2 sine 2t plus u 2 pi t g of t minus 2 pi. And so now let me go ahead and plug in what g of t is. So g of t is, what I do is I just plug that in there. So I'm going to get 1 minus 1/2 sine of 2t minus 2 pi. And the thing about this sine of 2 minus 2 pi, this is the same thing as sine of t, because if you shift sine of 2t, if you shift by 2 pi, you have the same function because sine is periodic. So we could, make this even better. Someone might think that. Someone say, well, I don't need to do that, but I will do it. 1 minus 1/2 sine of 2t. And one of the things that just right off I would like to do, though, is to, well, maybe I was thinking I can check the, it's not that easy to check the initial value problem, actually, but, well, actually a little bit. I mean, if you put in, see, first of all, this function here is 0 when t equals 0 because of this part. Okay, so putting in 0 right here, you get sine of 0, which is 0. Now take a derivative, still this part's 0, 0. The derivative of this is going to be 1/2 2 cosine 2t. Put in 0, and you get 1/2 times 2, which is 1. And I think that was for y prime of 0. And that was our initial condition. So at least I can check by knowing it satisfies the initial condition pretty easily. All right, so that was, that's not super easy, right? That's like really getting into it. Okay, that's all.